Hello everyone, welcome to LeetCode Solver and I'm a LeetCode Solver. Today we are going to solve 19th problem in 30-day lead coding challenge and the problem name is search in rotated sorted array. Today I will also open the problem and solve it in a way that we have to solve in real coding interview challenge. Let me open the problem. Well, search in rotated sorted array. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. That is 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7 up to this and then after 0, 1, 2. So it can be rotated. The sorted initially there will be sorted array which will be rotated. Okay, if it rotates from this, like if it goes like this, then the final array is this. You are given a target value to search. If found in the array, return the index, otherwise return -1. You may assume no duplicates exist. Okay, there will be no duplicates in the array. Your algorithm's runtime complexity must be in the order of big O of log n. Well, nums given 4, 5, 6. Okay, we will be given a rotated sorted array, rotated array which was formed from the sorted array. Initial array was sorted and it rotates somewhere and it becomes like this. And then after we have to find some element over here. Like if 0 exists over here, then we have to return the index of that element and there will be no duplication, no duplicate value in the array. Okay, if I understand problem correctly, then what if the array was not rotated? Then the solution to this problem is big of log n actually, which can be achieved by doing binary search. We can do a binary search to the sorted array so that we can easily tell the index of the particular target element if the array was initially sorted. Now, whether we can apply binary search over this rotated sorted array or not, we have to look into this and how we can apply binary search. Well, let's see another example. In the same array, if we search for 3, we have to return -1 because it doesn't exist in the given array. And the good point is the array is sorted and rotated. That means the element will be some kind of increasing order, like in the increasing order up to some point, and there will be one gap, and then after element will be again increasing. So there will be two sorted parts in given array. So we can note this. Also we can note that there is no duplication in the given array. This is a good point. And what we can note down. Now let's see how we can use this information in order to search in the given array in as much lower complexity as possible. The obvious solution is brute force solution. Brute force approach will be just iterate over array and check whether target element exists or not. exists or not. So which will cost us big of n time complexity. Yes, so for the brute force approach, now let's utilize the given information that there will be two sorted parts in the given array. Now let's think about the best approach, the good approach that we may apply. So what I'm thinking right now is whether we can apply binary search algorithm over here or not. I think we can apply because the array part can be partitioned into two sorted array parts. Basically, binary search will partition the array. Basically, how binary search work, it always partition the array into two subarray, and all those partition will, in this partition, now we have to now choose only one partition out of two partitions, and we have to do search over there in the same manner, so that if we choose this partition, first partition, then we can subdivide this partition into again two different partition, and we have to search over there, and finally if the partition size is 1, and we reach to the solution. So this is how binary search algorithm works. And if we can partition the array, and if we can ignore one of the subarray, then we are good to go. Well, let's apply binary search over given array, which is this. Then if we somehow can eliminate one subarray out of two subarray formed by middle, then we can apply binary search over here. And let's say target element is 0, and for finding out the two partition, we have to find a mid value, which is 0 1 2 3 4 5 6 6 divided by 2, which is 3. So mid index is 3. So we have two array 0 4 5 6 7, which is one subarray, and lower range, and 0 1 2, which is higher range. And we see that the 7 over here belongs to first part of the sorted array, and the value we are searching 0, which belongs to second part of the sorted array. So we have to move to the right side, so we can simply ignore this, and we again find the mid value. Mid is 3 by 2, which is 1, and we have two partition now, 0 1 and 2. Now we are here, mid value is 1, and we can make a decision that now we are in second part of the sorted array, and requirement is also second part, and now we can simply apply binary search if else condition, because we are already in a second part of the sorted array, and we see that the value required is 0, which is smaller than 1. So we move to this array, lower range array, and ignore the upper range array. So we move to this, and we will cancel out second part. So now here we find the mid value, which is 1 by 2, which is 0, and we see that we have two partition, 0 and 1, and the mid value is 0, and we see that we already reached to the our goal, we find this value, so finally we will return is its index, which we can get it keeping calculation of actual low and high index from the beginning. So finally we got the answer. Well, in this way we can solve the problem. And as we are doing binary search, so this is basically log of n, because in each step we are partitioning the whole array into halves, and from that halves again we partition that into another half, and from that half we are partitioning this into another half, so until we reach to the 1. So we are partitioning log of n times. That's why the complexity is big of log n. Well, we can also prove this uh, by like how many times we divide the given array of size n. So first of all we divide it, and again next time we divide it, again we divide it. So basically if we formulate this, what is happening, we can say that we divide the array until we reach to the size n, size of 1. So after some times, after dividing, we reach the array of size 1. So we can say we divide it x times, then after the size of the array will reach to 1. And now we can reformulate that equation to make it 2 to the power x equals n, and if we apply log to the both side, then log of 2 to the power x, which is equal to log of n. And now we can easily apply log, and we see that log is of base 2. Basically in computer science we apply log of base 2, and log of base 2 of 2 will be 1. So we can say that x is equals finally, which is 1, so x is equal log of n. So in this way we see the complexity of the solution is big of log n. Let's go for implementation. So let's find the range of the given array in the beginning, which is low is 0 and high is n, say which is the target. So we can also calculate the length of the given array as nums dot size, and high is n minus 1. We find out the index of both sides. And now the two things we need to consider, that whether the target exists in first partition, as there are two partition, whether the target exists in first partition or in the second partition. So we can find out that target exists in first partition, boolean target exists in first partition, which can be with the variable will be valid if we say that current the nums 0 is smaller than or equals to target element. Then we see that the target exists in first partition. Well, the spelling may be wrong. Otherwise the target will exist in second partition. Well, let's, depending upon this, we can change our range of the subarray after partition, after doing binary search and while making decision. So let's let's apply binary search. So while applying binary search, we can make the decision of our range depending upon this boolean value, whether we have to search in the first partition or to the second partition. So let's say while low is less than or equals to high, we will find the mid index, which is equal to low plus high divided by 2, and this mid index, where does it rely? So let's find a boolean mid value is in first partition. How we can find this? Like we can if the mid value exists in first partition, then definitely the same goes here. Norms of 0 should be less than or equals to norms of mid. Mid value exists. Mid value is in first partition. A target is in first partition is in. Okay, so if both of these conditions satisfies, like if target is in first partition and if the target is in first partition and mid value is not in first partition. If this is the situation, mid value is not in the first partition but the target is in first partition, then we have to lower our we have to take the lower range, so our high will be equals to mid minus 1, because we are in mid value is in first not in first partition, so that we have to go to the left side, so we change our high value to mid minus 1. Also we can put another condition that target is in first partition, target is not in first partition, that means target is in second partition, but mid value is in first partition. So our mid value is, this mid value is in first partition, but our target was in second partition. If the target was in second partition, then we have to go to the right side, so we change our low value to mid plus 1 to go to the right side of the array. Otherwise we are in the same we are in the same we are in the same partition where we need to do a normal binary search, like either we are in first sorted array or we are in second sorted array. So we are now do normal binary search, which is like if norms of mid is greater than or equal to target. I mean, if it is equals, let's say just return I mean, we can apply this equals condition over here as well. Equals to target, we can simply return mid. Otherwise, if say norms of mid is greater than target, so mid value is greater, then the target should exist in lower partition. So we have to have high equals to mid minus 1. Otherwise we have to go to the right, we have to choose the right sub array, so it will be low will be equals to mid plus 1. So in this way we will do a binary search and finally find out the value, and definitely it will return mid. If it if the target was in array. Otherwise we have to return -1 according to problem statement. Well, let's see how it works for this case. For this case, I already explained, right? Like mid value will become 3, and the let's define what is the boolean value for this. Boolean value will be false, because target is not greater or equals to 4, so this value is false. And when it goes here, we see that 3, the value at 3 is 7, and to calculate this true or false, we can say that 7 is greater than 4, so it is true. So our this mid value exists in first partition, and but the target itself is in second partition. So we see that target is in first partition. This doesn't valid. The target is in first partition, not in first partition, so target is in second partition. This condition satisfies, and also this condition also satisfies. Mid value is in first partition, so we will change our range to go to the right side. So our mid value, our low range, will be equal to 4. So our as a whole range is current. Initially the range was like 0, low was 0, and high was 0, 1, 2, 3, 4, 5, 6. 6. Now our low becomes 4. So basically this is telling us that we choose second half of the partition. Well, okay, now let's after happening this, we will again move to the while loop, which is true, low is greater than equal to 6. Now we find the mid value, which will be 4 plus 6 divided by 2, which is 5. 10 divided by 2, 5, and the value at fifth position is 2, 3, 4, 5 position is 1. And we see that 1, the condition nums of 0 doesn't satisfy. Nums of 0 is uh, this condition becomes false. Well, and we see that this is also false, this is also false, so both are in second partition. That means target is in second partition and mid value is also in second partition, so both of these conditions do not satisfy, and it goes over here. And we see that nums of mid, which is 1, is not greater, it is actually smaller. Yeah, it is actually greater than target 0. So we will change our partition to become the lower, to take the lower one. So now our high becomes mid -1, which is 4. So our high becomes 4 again. So we are taking this smaller range, the left range, and in the left range we have only 0 now, and we calculate the index as the mid value as 4 now as well, and we see that the mid value is in first partition also becomes false. That means it is in second partition, and none of these, if it will goes to none of these condition, and it goes over here. Before that there is a if condition, which is already satisfied. Say 4 is equals 4, so it will return the mid, which is, I mean, 0 is equal to 0, 0 is equal to 0, and which returns its index, which is 4. So finally we get 4 as the answer. So let's run the code and see whether there is any compilation error or, okay, well, compilation error in line number 27. Yes, because we define a variable. Okay, let's test with In the same array, let's test with 7. It should return 3. Okay. Now let's test with something of size 1. And if size becomes 0, then if the given array is empty, what should we return? Maybe -1. So let's put a condition over there. Then we will return -1. It should give us 0 as an answer. No, -1 as an answer. And if it is 4, it should give us 0 as an answer. Yeah. Well, let's submit the problem. Accepted. Runtime is not available. Okay. Runtime is 8 millisecond and memory usage is 6.5 MB. Well, thank you so much for watching this video. Hope it helps you. And if you have any other solution approach in your mind, please feel free to comment and share your ideas. And please feel free to subscribe if this video helps you. And if you are willing to prepare for the coding interviews of this channel will be helpful to you. Thank you so much. Have a nice day.